welcome to my new video. Today we discuss Hermite interpolation formula. Little bit further in unequal interpolation, unequal interval interpolation. Yeah, previous video you can watch the Lagrange's interpolation formula for unequal interval. Now little bit further Hermite interpolation formula. So first have a look what is Hermite interpolation formula, and then we go through examples. So for this Hermite interpolation formula, there is make use of only certain number of function values in the formula, and this Hermite interpolation formula that is look like y is equal to summation I going from 0 to n yi ai x plus summation I. There are two terms in this formula. One is the function itself, and the second is with its derivative yi dash bi x. What is ai and bi represent? That ai and bi represent by this term 1 minus 2 x minus xi li dash xi. L is the Lagrange's coefficient, or we can say Lagrange's interpolation. So what is Lagrange's coefficient? For example, L0 x0. L0 x0 is L0 x0 x minus x1. If we have 2 points for linear equation x0 y0 x1 y1, you watch already in my previous video. So L0 is x minus x1, x0 minus x1. L1 is x minus x0, x1 minus x0, and so on. So L2, L3, L4, and then L dash means the derivative of that Lagrange's coefficient, then Lix whole square, and similarly our second term Bix is given by x minus xi Lix of square. So this is the Hermite polynomial. I don't want to show you how to prove it or how to derive it. Just we directly proceed for the examples where Li is the Lagrange's coefficient or Lagrange's interpolation. So first, very basic, find the third order Hermite polynomial formula for xi yi dash where I is 0 comma 1. So there are 2 points, I is 0 and 1, means x0 y0 y dash 0 x1 y1 y. If they are given, then what is our Hermite formula or Hermite polynomial equation for finding the values regarding function? So proceed with this, or substituting these values h3x. First is the summation I going from 0 to n. So 0 and 1, we have each term have two terms for I is equal to 0 and for I is equal to 1. Similarly here also for I is equal to 0 and I is equal to 1. So let's see. First term is minus 1, 2 x minus x0 L0 dash x0 L0x whole square. See. Okay. Then the second term is with 1. So, and the second term, before second term we have to substitute yi also, because in yi is for 0 it's y0. Next, plus 1 minus 2 x minus x1 L1 dash xi into L1x whole square times yi is y1. Similarly for 0 and 1, if we want to find out 3 points 0, 1, 2, 3, then we have to go for x2 term also. Similarly for B part is x minus x0 L0 x0 square y0 dash. This is y0 dash plus x minus x1 L1x whole square y1 dash. This is y1 dash, where L0 is x minus x1 upon x0 minus x1. If we consider, or we already know, or we consider h1 is x1 minus x0, then this L0 is our x minus x1 by minus of h1. Then the derivative of x is 1, so it becomes minus 1 by h1. Similarly for L1, x minus x0 divide by x1 minus x0, same x1 minus x0 is h1, derivative of x minus x0 by h1 is x, d by dx of x is 1, so it gives 1 upon 1 minus h1. we substitute these values in the formula, then we can see what is the given terms. So I can show you. When we substituting these value of L0, L1, L1 dash, L0 dash in this formula, then it looks like 1 minus, because of this our L0 x0 is minus 1 by h1. We substitute here, so it becomes plus 2x minus x0. This become h1 because of this. Next, L0 x square x minus x1 by h1 whole square y0 plus, similarly we can substitute here also our L1x, this one L1 x1 is x minus L1 is x minus x0 upon x1 minus x0. So x minus x0 we should write x0 minus x, minus taking common, this is x0 minus x, minus minus become plus, and then the whole square. Similarly we can substitute in b part, and the third order Hermite polynomial is looking like this. Next we proceed for another example to find the using Hermite formula for find the polynomial and then the regarding values. So I will show you how to find the polynomial. What is the example? Express y as a polynomial in x using Hermite formula. Using Hermite formula is little bit lengthier as compared to Lagrange's, because there are two parts, ax and bx. So we have to calculate separately. Simultaneously we have to calculate the Lagrange's coefficient also. We are given x, y and y dash regarding value is minus 1, 0, 1. Regarding value y is 1, minus 1 and minus 1 and so on, and y dash also given. So we can, this is x0, x1, x2. First let's find the second order Lagrange's polynomial. So what is Lagrange's polynomial? We can learn already in previous. L0x is x minus x1, x minus x2 upon x0 minus x1, x0 minus x2. Substitute all the values, so it becomes this. Similarly L1, similarly L2. Then the L0 first order derivative means d by dx of L0x, we have to derive 1 by 2, it becomes 2x minus 1. Similarly when we derive this, we will get L1 dash x. Similarly we will first order derivative of this given by 1 by 2, 2x plus 1. When our L0, L1, L2 comes, L0 dash, L1 dash, L2 dash comes, then we have to calculate ax and bx. So ax also for a0, a1, a2. For there are three terms, a0, a1, a2. Similarly for b, b0, b1, b2. All 3 plus 3, 6 term when we substitute in the Hermite formula, then we will get the required solution. So it's little bit longer. So let's proceed to find the a0, then a1, then a2. Calculate a0, a1, a2, b0, b1, b2. So a0, what is formula mine? 1 minus 2x minus x0. So x0 is what? I can see, you can see in the x0 table. What is x0? x0 is minus 1. So it's minus minus plus 1. Similarly, then next term is li dash x0. Okay, so when you put x0 is minus 1, you will get this term times L0 x0 whole square. When we put this and simplify it, you will get 1 by 4, 3x5 minus 2x4 minus 5x3 plus 4x. Similarly a1x, you will get x4 minus 2x square plus 1. Proceed with a2, a2x is given by this. Now what is our bix? Bi is x minus xi, L1 x whole square, Li, sorry, this is Li. So b0 x minus x0 is x plus 1 and substitute L0 x whole square. So it will become this. b1 is this and b2 is this. All substitute in the formula. So what is our Hermite formula? I going from 0 to ai x yi. It means a0 y0 plus a1 y1 plus a2 y2. Then I going from 0 to 2, b0 y0 dash plus b1 y1 dash plus b2 y2 dash, which y1 y2 y0 dash y1 dash y2 dash given by the table. So when we substitute all these values in this formula and then simplify it, you will get the result, or you will get the polynomial, that is y is equal to x4 minus x minus 1. This is the required polynomial, or what we want to find out. From this polynomial we can find any equation, any value for x, if x is given regarding y. So if x is 0.5 for example, then y, if you substitute here 0.5, y becomes minus 1.4375. So that's all for Hermite polynomial. Next we will move for divided difference interpolation. That's all for today. Thank you very much.